sheet. The
Oh, is this not it?
No, it is. It just doesn't have the homework attached to it. Because two of the ones that printed did not have it, but I did print enough so it looks like at least one or two other people took extras. Okay, there we go. So, no one has homework questions? No. Main reason I know we don't have homework questions is because we have not had a homework assignment yet.
Pull up your hair. Pull up your hair. Let's see that hairline. Mine's falling apart.
That's straight. At least it's not like.
It's mine bad? Oh, no. I'm balding on one side.
That's why you have that bandana.
Yeah, I'm bald. Like, look, on the sides here, I'm bald. I'm trying to think of what looks like this.
All right, guys. So we're going to be going over writing transformations of quadratic functions. Now, this isn't new. We've done this stuff before. We did this no. So, note sheet from yesterday, because I cut it at that spot where it just went to the blank screen so that we had enough time to talk about these today. But we're talking about transformations. Now, this form of the quadratic is called vertex form. And they name it that way because, well, it's actually exactly what it is. The vertex is the point h comma k. And it is the lowest or smallest point where it turns from going up or down or up. So when we look at a quadratic, this point, this lowest point for this one here, would be the vertex. And the h value, the value of h inside the parentheses, and the k value we add on to it is the vertex. So they call this vertex form because it contains the vertex. Exactly why they call it that. Now, this other part, you do not have to write it down because we've talked about this yesterday, and we've talked about it before previous chapters. A, the number in front of the parentheses, if it's negative, is our reflection across the x-axis. If we have a value there greater than 1, it's a vertical stretch. If we have a value between 0 and 1 there, it's a shrink. We have those there. The h indicates our horizontal translation, our left or right translation. And h is the value that we have. And k indicates vertical, either up or down. And we talked about these yesterday. We talked about these in chapter 1. We're seeing them again. And the last part of this section is writing a transformation. So we're actually using our transformations to change the function. Where yesterday we just named them, now we're actually applying them. And this isn't going to be any different than when we did these in chapter 1. And then after we do that, we're going to identify the vertex. Now, let g of x be a vertical stretch by a factor of 2, a reflection in the x-axis, followed by a translation of 3 units down. We have 3 transformations. And the first one we're going to do is the vertical stretch. So when we apply a vertical stretch, yes. So we'd have a f of x. This is our vertical stretch or shrink. Now the value of a is indeed 2. So we have 2 times f of x. Right there. You're good. Now f of x, we still have f of x. We didn't do anything to the x inside the parentheses. So technically what we're doing is replacing every x in the function f of x with x. Well, that just means that we have 2 times x squared. It really doesn't change anything. We just replaced x with x. X squared. Now, we simplify by multiplying. 2 times x squared is, bless you, 2x squared. Vertical stretch by a factor of 2 is done. I'm going to name this h of x. Questions on this so far before we move on to the next translation? Or transformation. So our next transformation is a reflection across the x-axis. And as we went over this in chapter 1, it was negative f of x, or we could say negative h of x, because we say h of x because we're talking about the function we just applied the vertical stretch to, not the original function. Now in this case, just like the previous one, we still have h of x. We didn't apply anything or switch anything with x, so it's just still 2x squared. And if we apply the negative to it, we get what? Yes. And we could call this m of x. We just need a way to name it. So vertical stretch by a factor of 2 is done. Reflection in the x-axis, done. And the last one we need is what? A translation of 3 units down. Yes. It would be mx minus 3. We do need to apply it to the function, but yes. Yeah, so we need to replace m of x with its function, which is negative 2x squared minus 3, which ends up being just negative 2x squared minus 3. Because there's no like terms to affect it, so we just get this here. And that's it. Questions on this here? As I believe most of y'all feel pretty comfortable with these transformations. Up, down, left, right, stretch, shrink. Yes. And again, I said this earlier today, I'm not expecting y'all to be masters of this and be able to do this flawlessly every single time. I just am expecting y'all to have an understanding of it and know how it works. Now, the next part we're looking at is the vertex, h comma k. And this is going off of our a times x minus h squared plus k. So h is inside the parentheses, k is outside. H is our number we're subtracting from x squared, and k is the number we're adding and subtracting on the outside. Well, in our case, the value of k is what? Negative 3. Because it's exactly like it looks like. It is negative 3. We're not going to have to plot it. Now, what's our value of h? That's a, yes. It is indeed 0. Because we don't have to have one. Or we do have one, it's just that its value is 0. Now, for the original function, I didn't say this in earlier class, I probably should have. The vertex for the parent function, this x squared, is the point 0, 0. And our translations left to right, up, down, move it. Now, did we move or use a translation that moved the function left to right? Horizontally, no. We didn't move it left to right, correct? So that means the x value of the vertex is still 0. We didn't move it. But we did move it down 3. So the y value got moved down 3, giving us this here. Horizontal really affects the x-axis, the x value of a point. The vertical, stretch and shrink, up and down, affects the y value. So the vertex for this is 0, negative 3. Questions on this here? Oh, way too far up. And if we notice this here, 0, -3, in this case, is the biggest point because all the other y values are smaller than it. They're going down. So it is the biggest value for this here. That's the vertex. Questions on this here? Are you ready for the next one? Let G be the graph. Let the graph of G be a vertical shrink by a factor of 1/2, followed by a translation 2 units up. Now the graph f of x equals x squared. Write a rule or find the equation and find the vertex. So the first one is a vertical shrink by a factor of 1/2. So we're still just like the last one, a f of x. Well, our a value in this case is 1/2. The only stretch or shrink where we have to flip it is not with vertical, it's with horizontal. So we can leave it as 1/2 f of x. Well, now we need to plug the function in. Well, we just have f of x. We don't have f of 2x or anything inside the parentheses besides x. So we just replace f of x with, now, yes. We would multiply them together and indeed get 1/2 squared. I'm going to call it h of x because the problem wants the last step or the last, what we finish it with to be g of x, but again, I'm not focused on that. I'm more focused on the equation itself. So we did the first one. Then we have a translation of 2 units up. So if we wanted to do this step by step, we would say h of x plus k. But we know that the k value is +2, yes? Are we really doing anything to h of x when we plug it in? No, I mean, we're adding the 2 to the function, but I can still replace h of x with 1/2 x squared. I'm not having to plug anything into h of x specifically. And if we simplify, we get that g of x is equal to 1/2 x squared plus 2. That's it. That's our function. Questions on this here before we find the vertex? Vertex, h comma k. Well, again, what would the k value be? 2, and it would be positive because it's +2, yes? What would the h value be? 0. We don't have one again. It did move it left or right. But that's it. Questions on this here? H is this value here. It's our horizontal, our left-right translation. Questions on this here? We feel comfortable with this here? Yes? This here is the last one where we're going to deal with transformations here. And yes. Now, I'm going to shrink it down a little bit because easier to see everything all at once. But the first one we have is a horizontal shrink by a factor of 1/3. Now in this case, we're going to have f of a times x. Because for horizontal, the a is inside, vertical, it is outside. So I think you had it flipped, yes? But the factor of 3 is correct, because with horizontal stretch or shrink, we have to flip the value that they give us. Since it says a horizontal shrink of 1/3, our actual value that we plug in is 3. Be nice.
We're here to buy suckers.
We have none.
Okay.
Unfortunately. So we can replace a with 3. So we have f of 3x. Now this one here is the first one that we've actually had something different than just f of x or h of x. We have f of 3x, which means every x in the function is going to have to be replaced with 3x. So what we get is parentheses 3x close parentheses squared. And we can leave it as that there. I mean, we could go on and simplify it and multiply 3x times itself, 3x, which would give us 9x squared, but we can leave it as this here. So horizontal shrink of 1/3 done. The next one is a reflection in the y-axis. Now, x-axis was our negative f of x, but for y-axis, it's f of negative x. In this case, we'll say h of, because we're talking about h of x and not f of x anymore. Now, just like with our horizontal shrink, where we replaced every x in the function with 3x, now we're going to replace every x in the function h of x with negative x. So we'll still have the first parenthesis. We'll still have the 3, but instead of x inside the parentheses with the 3, we now have negative x. And our 3 times negative x is negative 3x squared. So we can say m of x is negative 3x squared. Questions on horizontal shrink of 1/3 or the reflection in the y-axis? We feel okay with this here? Yes? Now the last thing is a translation 2 units up. So if we went by the definition, we would say m of x plus k. Now the k value in this case is going to be 2, and it'll be positive because we're going up. Yes? And what's m of x? Negative 3x squared. That's actually it. Questions on any of this here? Question on anything we've done? What's the last thing we need to find? Vertex. It would indeed be 0, 2, h comma k. Because this is coming from the general form a times x minus h squared plus k. So the h value comes from inside. Because really what we have is negative 3x plus 0 squared plus 2. Because since we don't have a value in that h's spot, it will be 0. And that's how it's been for all these here. The plus 2 on the outside gave us our k value of 2. Let's actually look at one that doesn't have that. Now again, we're comparing this to a times x minus h squared plus k. And our vertex is the point h comma k. And this is really for our y equals. The vertex is always h comma k, but we do have to be careful. There's another one, and we'll get to it, and I'll point it out when we get there. So we won't worry about it now. Now looking at this first, what is our k value in this function? So -1 for k, because it's exactly like it looks, we can grab it there. What is our h value? Almost. It is opposite, because if we look at the general form, it is what? X minus h, yes? in the equation we have x plus 3. The only way I can change that minus to a plus is if the value of h is negative. Because the negative and negative makes a plus. So inside the parentheses, if we're taking a value for the vertex, we have to change the sign from positive to negative or negative to positive. Because if, I erase this here, and we said minus x minus 3, the vertex would instead be 3, negative 1. If we see the difference there. Okay? We ready for what's next? Yes, I will work on that right now. So on the homework, 3 through 11, 17 through 21 odd, all you're doing is describing the transformation. You do not graph. Do not graph them. 27 through 29, you're describing the transformation and naming the vertex. So 27 through 29, describe the transformation and name the vertex.